So for checking the accuracy and long-term stability of my meters, I am using my homemade multi-reference tool. Internally it has several voltage references, some precision resistors, some precision capacitors, and a precision current reference. The voltage references are not selected by absolute long-term stabilities. There are much better ones for that, but I selected them for their initial reference, and the most precise one is the 10 volts reference, which is accurate to 0.01%, which is even a bit better than both of these meters here. And I'm using them to verify that my meters are still within specification. So as we can see here, when selecting the 10 volt range here, both meters are within 1 digit of accuracy. This one here sometimes jumps to a 1 here. This one is 1 digit low, but it's still way within specification. And if we switch here, we reverse the polarity. That's the functionality here where I have a polarity switch, so I can easily test whether there are any inaccuracies when reversing the voltage. We can see that it takes a while for the measurements to actually stabilize, but they still look to be within specification. This one here is probably 3 digits low, this one here just 2, so that's very fine. We can look at a much smaller range here. That's the 1.25 volt reference. Again, we can see here that both are basically accurate to 1 digit, which also again is well within their specifications here. I have not yet tested all of the ranges, but it looks as if this is as it should be. One thing to note here is that the multicomp meter did not come with a calibration certificate, which kind of surprised me. The Agilent here, even it was way too old, came with a calibration certificate. I think for a meter of this precision accuracy, it should always be provided, so you know that at least when you get the meter that someone has checked that it is within its specification. We can also have a look at the resistances here. So for that we should just connect 1 meter. That's the 1K resistance. Actually, it's also a 0.01% resistor here in this meter, but probably the actual leads here play a role, so probably I should use 4-wire measurement or relative measurement for this as well. But even this run here is it's 0.2%. Which is probably would be out of specification, but I would need to check for the 4-wire measurement here. And similarly, when we connect this one here, it actually shows the exact same value, so probably it's the resistance of the wires and the connectors here. So again, 4-wire measurement would be very helpful.